Okay. Today we will talk. We will continue يعني free body diagram, talking about the inclined plane. But before talking about the inclined plane, let's solve this example here. Here we have this block. This block has been affected by three forces. The applied force, which is 40 Newton to the right. There's a friction force, which is 35 Newton to the left. And there's a normal force, which is 10 Newton up. And its mass is 35, or let's make it 3.5 kilogram. So here now, as I would say, this block, there's an F gravitational force that is affected, which is M times G, which is 3.5 times 10, 35 kilogram. Now, and here we have normal force. Now look at this one here, the applied force. It is F friction. Now the applied force here, it's not on the x-axis or y-axis. It is between them. It is, it's applied with an angle. So this one now here, I need, it needs to be resolved. It will be F or 40. Let's make the angle as an example, the angle theta here. I forgot to write it. Let's make it 40 degree. So it will be here 40 cosine 40 and 40 sine 40. So after that, let's draw now the free body diagram. I have here 40 cosine 40. Here I have F friction, which is 35 Newton. Here I have 10 Newton. Here I have 40 sine 40. And here I have 35 kilogram. So now I wrote all the forces that were affected by this block here. I'll present it in a free body diagram. Then after that, I want to find now the acceleration that the acceleration of this block here. To find the acceleration now, we will use the Newton's second law. The Newton's second law says that if you have F equal M times A, or A is F net over the mass. So the acceleration here is a force on the net force over the mass. But here, as you see, we don't have an acceleration on the x-axis. I have an acceleration on the x, and I have an acceleration on the y-axis. So to find the acceleration on the x-axis, I need to find the net force. So let's find the acceleration on the x-axis. It will be the net force over the mass. Let's see now the net force on the x-axis. We have (40) cosine 40 minus 35. This is for AX. This is for the FX over the mass, which is 3.5. Don't forget, I change it here to 3.5. Then 40 cosine 40 minus 35, negative 0.435 over 3.5. It will be negative 1.24 meter per second square. So an AX now is negative 1.24 meter per second square. So it's gonna be now to the left. Let's now find A sub y. This A sub y here, it is Fy over M. So F sub Y, it is here. We have 10 plus 40 sine 40 minus 35. So 10 plus 40 sine 40 minus 35, it will be 0.71 meter per second squared. So I found now A sub x to this side, on the negative x-axis, and I have now 0.71 meter per second square now upward. I need to find now A, or the acceleration. To find the acceleration, as we said before, we will use Pythagorean theorem here. We will say it is ax squared plus ay squared. So it's negative 1.24 squared plus 0.71 squared.
Teacher?
Yes.
Teacher, how do you bring the FG, the force of gravity?
Sorry?
How do you bring the force of gravity?
M times G. 3.5 times 10.
Isn't it 18? Okay.
This is 10. So it is 1.11 meter per second square. This is an resultant acceleration. Now let's see, or let's find the angle here. Now, to find the angle that the acceleration here is, or that the acceleration is far from the x-axis, we say theta is tan inverse of ay over a sub y over a sub x. So it is tan inverse of negative 1.24 over 0.71. So the angle theta, it will be now tan inverse of negative 1.24 over 0.71. So it will be negative 60 here negative 60 that means it's 180 minus negative plus 60 here, or it will be, no, sorry, it was not in the second quadratic, it will be in the second one, so it will be here. Here, as you see now, the tan inverse of negative 1.24 over 0.71 is negative 60. So the angle here we said, as an example, we said here, it will be here. We said it was here, negative 60. So this negative 60, that's mean it was by 120. Let's remember here. That's
Is it in the second quadrant?
Yes. So tan inverse So it will be 120. How I know? I add 180 minus 60, it will be 120. Is it clear for the?
Yes, teacher, what about the other side, the F equals 35 and FG? The angle between them, it will be the angle between F and FG.
The angle between F and the x-axis?
Yeah,
I suppose that is 40.
oh, okay.
Here, I wrote it here. Okay. Do you have any question?
Teacher, you said last period you're going to solve an example with tension. Are we going to do it?
Yes, no. But this is let's just a revision before talking about the inclined surfaces. Do you have any question here?
No.
No,
Teacher,
thank
can you do another example?
I will talk about now the pulley, like a tension, like this. And for these type of questions, we solved in the previous week. We talked about the box and how we solve the affected forces. And now we'll talk about the inclined surface. Okay, it will have to have the same idea. Now the inclined surface. For the inclined surface here, as you see, we have these two masses. These two masses, they are moved by a pulley. This pulley here, as you see, this pulley here now is connected between mass 1 and mass 2. And it is a fixed one, and it's just move the two masses. Now, this is the pulley. So what is the pulley? A pulley of a kind of wheel that turns on an axis, like this picture here. This is the pulley. Here, just as a definition, it's not important for you. You will talk about it, inshallah, next semester. The fixed pulley here, what is the fixed pulley? We have the three types of pulleys: fixed, movable in one direction, and movable in two directions. Now, the fixed pulley here, it doesn't travel with the load. As you see, it's fixed, and it's only changed the direction of the applied force. Now, let's have this example here. Here now, we will talk about these two masses. These two blocks, they are on friction-free lab. There's no friction here on a bench that's connected by a string and pulled by a second falling object. This mass is pulled mass 1, or mass 1 pulled mass 2. Later on, we will talk about, we will solve another example, also without friction. Here, we will solve this example, but with a friction. And then we will talk about also the two masses that is affected by a pulley, but on an inclined surface. Let's start now with this example here. Here now, each block on a friction-free lab bench is connected by a string and pulled by a second falling block. Find the acceleration and the tension of the string. Let's make M1 is 3 kilogram and M2 is 1 kilogram. So here, M1 is 3 kilogram and M2 is 1 kilogram. Now they told me that there's no friction here. Now let's see what are the other forces that is affected by this masses. Now, since it is connected by a string and pulled by a pulley, so there's a tension force here, and there's another tension force here. Since we have the same string, the same pulley, so we will have the same tension. There's no T sub 1 and T sub 2. We have the same string, we have the same pulley, so we have the same, so it applies the same tension for both mass 1 and mass 2. So let's talk about now, or let's draw the free body diagram for the mass 1. So for the mass 1 here, we have a tension force acts on it, but there's no friction. And for a mass 2, we have a tension force upward, and we have an M2G downward, or the gravitational force. For the M1 also, we have a FG, or gravitational. But I didn't need it to find the tension, or it can be neglected. I didn't need to define a tension. I am only talking about how the mass is moving. It's moving to the right or to the left. So I need only A sub x. Here, M2, it's, as you see here, it's affected by upward and downward force, affected by vertical forces. The tension upward and the gravitational force downward. So what does it mean? We have an acceleration for them and we have an attention for them. Let's find now the acceleration for M sub 1. Oh, let's write it here. We said an acceleration is a force over M. So F net here is only, look at here, we have only the tension. So I will say tension over mass 1, which is 3. So here, both of the acceleration and the tension is unknown. So I will have the first equation where 3A equal T. This is an equation number 1. Now, let's find an equation number 2 for the mass 2. Here now, also we said F, the acceleration, sorry. So the acceleration here is the force over mass. Now look here. What the forces that is acted by M2, that's applied to M2. We have a tension. We have a tension and we have M2G. So we will say tension minus M2G over the mass 1 equal the acceleration. So the acceleration is a tension minus 1 times 10. So here an acceleration is 10 or tension minus 10. So we have now two equations, two systems of equations with two variables, A and T. Let's now apply here instead of, so A is 3A minus 10 by substitution. Let's replace T with 3A. Minus 3A minus 3A. So I have now negative. 2a equal negative 10. So the acceleration here is 5 meters per second squared. I need to find now the tension. Come back here. 3 times 5 is 15, so the tension will be 15 Newton. This is an example for masses that is affected by attention. I have here to find, or they asked me to find the acceleration and the tension of the string. We have a same string, so we have a same tension and we have a same acceleration. We need to find them. How? By find the forces that's applied for an M1. Let's draw the free body diagram for it. The free body diagram for a mass 2. Then by writing the equation, we will find the acceleration and the tension. Is it clear?
Yes.
Teacher, can you repeat how did you find the step?
Here?
Yeah, that's the bit.
Here. After we have two equations, we need to find an acceleration. So look at the equation number 1 here. Let's please back to it. Now, using equation number 2. Here, A is t minus 10. Now, but t is equal or equals to 3a. So I will replace t with 3a minus 10 equal a. I will isolate now a on a side and a constant on the other side. Minus 3a minus 3a. So negative 2a is negative 10. So the acceleration here is 5 meters per second squared. Now I found the acceleration. Now I need to find the tension. How? Let's go to equation number 1. In equation number 1, we said that 3 times a is a tension. And we found a is 5. So attention, it will be 15. And since attention is a type of forces, so we will say 15 in Newton. Is it clear now? I will solve now another example.
Yes, thank you.
Yeah.
Now, here also we have the same question but with different masses. M1 is 2 kilograms. And M2 is 3 kilograms. I will repeat the same steps but with different numbers. Here we have attention. Here we have attention. Here we have an M2G. We need to find an acceleration and a tension. Let's draw now the free body diagram for M1. We have only the tension that is applied by M1. And for M2, we have a tension up and we have an M2G, or we can 3 times 10, which is 30. So, acceleration is a force over M. So, an acceleration here, what is the force that's affected by an M1? It's only the tension over M1. So, and M1 here is 2. So, A is attention over 2. Or we can say now as 2A equal attention. This is equation number 1. Now, let's use the same equation here, but for the second mass. Now look at M sub 2. What is the forces that is applied on M sub 2?
It's going to be gravity and the tension upwards.
Yes, so we will say attention minus 30 or m2g over what? The mass. What is the mass of the second block?
3.
It's a 3. So the equation here, let's make a cross product. We will say 3a equal attention minus 30. This will be an equation number 2. Then 2a is equal attention. So let's replace now in equation number 2 here. In equation number 2, let's replace, we have a 3a equal t minus 30. Now let's replace place t with 2a. So a it will be negative 30 meter per second square. Here I put the masses from my mind, so maybe that's why there's the wrong numbers. Type, okay, let's make a mass 1 is 3 and mass 2 2. So here it's a 3, here it's a 3. So 3a equal t.
Between the 20, or it is 2a. Yeah, 2a. Okay.
Sorry here, so let's change the masses. Let's make mass 1 2 and mass 2, mass 1 3. Mass 1 make it 3 and mass 2 make it 2. So here it will be a equal t over 3. So 3a is the tension. The second one here, we have it as 2. So 2a is equal t minus 30. Now then, let's replace t with 3a minus 30. So minus 3a minus 3a. So negative a equal negative 30. So our acceleration here is 30 meter per second square. So by this way now we found an acceleration. Now let's replace it here. We will find that the tension here is 90 Newton. So we have here to find an acceleration and the tension of the string. We have a 3, mass 1 is a 3 kilogram, mass 2 is 2 kilogram. A is F over M. The force that acts on M1 is only a tension. So I will say tension over M1. The second one, for the same equation here, we have A is F force over M. Now the force that's applied to M2, we have an attention minus M2G over this mass 2. Here it has to be 2 also. Here it's not 30 because the mass is 2, not 3. Sorry, here it has to be 20. So 60. Okay, because here the mass is 2, so mg is 20. So by that, we found an acceleration and a tension of the string. Is it clear now?
Yes, it is.
Yeah.
Now, M1 is a 3 kilogram, M2 is 1 kilogram, and the friction here is 5 Newton. Find the acceleration and the tension of the string. It seems here we have only 2 minutes left for this meeting. So please lift this one and rejoin it.
Okay.